Okay, so the third sheet for the homework. So we've got highest common factor, lowest common multiple. Well, factors go into numbers, multiples are multiples, so they're times tables, so you're going up. So factors should be smaller or equal to the number we're dealing with. Multiples should be, the smallest it can be is the beginning number, and then multiples should always be getting bigger. So let's have a look at this question that's to work out. So Martin's organised a summer fair, bread buns and burgers. Bread buns are sold in packs, 40 bread buns, that's important, and burgers are sold in packs, 24 burgers. Martin buys exactly the same number of bread buns and burgers. So in other words, something in the 40 times table is going to be the same as something in the 24 times table. So what is the least number of packs assigned? So really what this question is asking you to do is find the lowest common multiple of 40 and 24. Quite often, quick way to do that is to write out the times tables. So the 24 is the smaller number, so I'll start writing out the 24 times table. So 24, keep adding 24, so 48, 72, 96, 120, and usually within a few lines you can start to see, well, 120 looks familiar, 4 times table for 40 is 12, so it looks like in the 40 times table we're likely to find 120. So for this one then, for the 24 burgers, we bought 1 pack, 2 packs, 3 packs, 4 packs, 5 packs. So our answer would be burgers, 5 packs, and for the buns, 1, 2, 3 packs. So for the buns, 3 packs. And each of those combinations will give us 120 of each, which is what they wanted, exactly the same number of bread buns and burgers. Okay, so this next question then, sharing in ratios, shop to sell CD and DVDs. So the headings are CD, DVD, and they're telling us the ratio is 3 to 5. So in this particular ratio then we have 8 parts, 3 of them are CDs and 5 of them are DVDs. So we're basically working in the 8 times table. So 3 plus 5 is 8. So it's asking us to work out the total number of CDs sold. So there were 728 altogether. So if I find out how many 8s there are in 728, remember this is a non-calculator paper, so we use our methods. So 8s into 7 doesn't work, so then we're going 8s into 72. Well, in our 8 times table we find that's 9, and 8s into 8 is 1. So each part of this ratio is worth 91, so that means we times everything by 91 to find out what's going on. It only wants CDs, so I'm doing 3 lots of 91. 3 90s is 270, 3 1s are 3, so the answer is going to be 273. Expanding brackets, you just got to remember that this means you're doing 3 times the bits inside the bracket. So 3 times 2g is going to give me 6g. It's like 2g plus 2g plus 2g, 6g's, and then 3 times take away 1, negative 1 is negative 3. So 3 times negative 1 is negative 3. So we've got 6g's altogether. Take away 3. So that's the answer for that one. Expand and simplify these. Again, apologies for the photocopy, but they are both pluses. And for this one, it was also a plus in there and a minus. So quite often on these grids help. So we'll draw out our grid. And what have we got? We've got x and 2, and we've got x and 3. Timesing. So x times x is x squared, x times 2 is 2x, x times 3 is 3x, and 3 times 2 is 6. Common terms, like terms, can be added together. So we have x squared plus 5x plus 6. 3x plus 2x is 5x, and so forth. So the answer for this one then is x squared plus 5x plus 6. For the next one, we've got to be a little bit careful here because we've got a minus involved, so we've got to remember the subtle difference here is the first bracket was x and positive 3, but we must remember to put the negative sign in for the take away 4 bit. So timesing again, so we've got x times x is x squared, x times 3 is 3x, x times negative 4 is negative 4x, and x times 3 is, oh, we've done that one. Negative 4 times 3 is negative 12, 1 negative, 1 positive. Answer is going to be negative timesing. Again, bring like terms together. So we've got x squared on its own, we've got 3x's take away 4x's, which is minus x, and we've got negative 12. So the answer here then will be x squared take away x, take away 12. Should check it works, of course, and so if we put in 1 as our check answer, then 1 plus 3 is 4, 1 take away 4 is minus 3, 4 times that is negative 12. Let's have a look. So 1 squared is 1, take away 1 is 0, take away 12 is negative 12, so negative 12, so it works. This one again, apologies for the copy, but it was a plus there. We've got to be really careful here because this is x plus 3 squared, so it's x plus 3 times x plus 3. So x times x is x squared, 3 times x and another 3 times x is 6x altogether, and 3 times 3 is 9. Could use the grid, but you get into a habit of just doing FOIL really. Multiply those, and then multiply the innards. So okay, right, rearranging. Rearranging t the subject, so that means we want to get t equals, again, apologies, this is a plus here. So rearranging, let's have a look. Rearranging means that we want t as the subject, so we've got v equals u plus 5t, so that means we've got to move the 5 and we've got to move the u. Always move the thing that's away from the letter in terms of it's separated by another operation, so we're going to move the u first, move things across the equals by doing the opposite operations. This, although we don't write it, has a plus in front of it, so the opposite of adding is take away, so we take away. So we come top down always. So v minus u equals 5t, because u take away u is nothing, it's gone. This means 5 times, so when that moves it's going to be a divide by 5. I want to leave t on its own, so it's the 5 that moves. So we divide by 5 that side as well, so we end up with v minus u divided by 5 equals t. So this answer here then will be t equals v minus u divided by 5. Okay, and the next one, it says we've got to do m equals 5n's take away 21. It wants n as the subject, so that means we've got to move the 5 and the minus 21. So again, move the thing that's separated by an operation first, that's not attached to the letter. So we've got minus 21, the opposite of that is add 21, so we add 21 to both sides, so m plus 21 equals 5n. The 5 times the n, so the opposite of timesing is dividing, so we divide by 5. So m plus 21 divided by 5 equals n. So our answer here is n equals m plus 21 divided by 5. Okay, so the last one, it says we've got p equals, again apologies, that's a plus sign. So we've got p equals 2q plus 10. We want q as the subject, so I'm moving plus 10 and I'm moving the 2 to leave q on its own. Q as the subject means we want q equals at the end. So opposite of add 10 is take 10, so take 10 from both sides, so p take away 10 equals 2q, 2 times q, so I do the opposite times, the opposite times is dividing, so divide by 2, divide by 2, so p take away 10 divided by 2 equals q. So here we have q equals p take away 10 divided by 2. Okay. Right, locus, loci. So there are 4 things that we need to realise for locus type questions. How do we know from this wording that it's going to be a locus question? Well, they're telling us several things. It's a scale drawing, so that means accuracy, so therefore we'll be using ruler, pencil, compass, protractor. It said a tree should be planted nearer to, so it's using these words nearer to something, within, the diagram shape the region, so it's kind of really implying get your compasses out, you know, do some locus work. So therefore, once we realise it's a locus question, there really are only 4 constructions that you guys need to realise for regions. And if it's a single point, say x, then the idea here, look, within point A. So we want to be within a distance from a single point. Well, that means we need a boundary line, and that boundary line has to be a circle around that single point. We've then got the idea that we might have a question with 2 points in it. So we might be saying we want to be nearer to Z than W. Well, if we want to be nearer to something, then there must be a boundary where I will be nearer to one than the other. So that's the straight line down the middle. Well, that normally means we draw our perpendicular bisector, the fish picture. If we've got 2 lines, so we might have 2 roads or something, X, Y, and Z, and they say that we want to be nearer to XY than XZ, then they're talking about an angle between 2 lines, so we need what's called the angle bisector. And that's where we draw an arc from the corner, and then where the 2 arcs cross, well, where the single arc crosses the 2 lines, we create two new points, so we draw from there, compass arc, where they cross. That's going to give us our angle bisector. The perpendicular bisector here, by the way, this is the one where you've got to open the compasses over half the distance between the 2 points, and then draw your circles such that, or pass the circles, arcs, such that they cross each other to get where you line up your ruler to draw your perpendicular bisector. If a question implies that you're going to be the same distance away from a straight line, say a road or the side of a building, between B and C maybe, then if we're going to be the same distance away from it at all times, then we end up drawing a parallel line to that. If it tells us to go all the way round the line, then of course we've got to realise that we've got semicircles at each end, and then we draw the parallel line for the other side. So parallel lines to a straight line. So let's have a look then. How can we use one of these for this question? Well, we've already indicated that nearer to AB, well, AB represents a line and AC represents a line. We want to be nearer to one line than the other one. Well, the two lines make an angle, so therefore I need to be drawing an angle bisector. So I get my compasses, open them a comfortable distance, and put my compass point on where the two lines meet, and draw the arc between the two lines. So the arc crosses the two lines at those 2 points. So again, if my compass is now on each of those new points, and draw an arc, part of the circle, roughly where we think the middle of the angle is. Then we get our ruler, and then we draw the angle bisector. So in doing that, I now know the boundary, where if I was over here, I'd be closer to the line AB, and if I was down here, I'd be closer to the line AC. It then gives us a second condition. We want to be within 5 meters of point A. Well, we remember the scale tells us that 1 centimeter represents 1 meter, so 5 meters is the same as 5 centimeters. So again, it's about accuracy, so we've got to be really careful that we are being accurate here. So we get our compasses and we draw 5 centimeters. So we make sure we're at 5 centimeters, and we put our compass point down, and then we draw the arc that crosses the garden. So that's our 5 centimeter line. Then we actually confirm that it wants to shade the region where the tree can be planted, so it needs to be nearer to AB, so it means it's going to be above the line somewhere, and it has to be within 5 meters of A, so that means we've got to be to the left of the boundary line for 5 centimeters. So we need to be above and within that, so we're basically saying shade in that. Okay, so that's the answers to the third sheet.